Good morning everyone. Today is the day 3 of the Python training. My name is Sejin Park and I will lead you from day 2 to day 5. So yesterday on day 2, we learned about essential Python libraries and setup. Today we're going to learn about IPython basics and Python language basics. Let's get on to part 1, IPython basics. In this section, we'll get you up and running with the IPython shell and Jupyter notebook and introduce you to some of the essential concepts. You can execute arbitrary Python statements by typing them in and pressing return. When you type just a variable into IPython, it renders a string representation of the object. The first two lines are Python code statements. The second statement creates a variable named data that refers to a newly created Python dictionary. The last line prints the value of the data in the console. On the surface, the IPython shell looks like a cosmetically different version of the standard terminal Python interpreter invoked with Python. One of the major improvements over the standard Python shell is tab completion, found in many IDLEs or other interactive computing analysis environments. While entering expressions in the shell, pressing the tab key will search the namespace for any variables matching the characters you have typed so far. In this example, note that IPython displays both the two variables I defined as well as the Python keyword and built-in function. Naturally, you can also complete methods and attributes on any objects after typing a period. Using a question mark before or after a variable will display some general information about the object. This is referred to as object introspection. If the object is a function or instance method, the docstring, if defined, will also be shown. Suppose we had written the following function, then using a question mark shows us the docstring. Question mark has a final usage, which is for searching the IPython namespace in a manner similar to the standard Unix or Windows command line. A number of characters combined with the wildcard will show all names matching the wildcard expression. For example, we could get a list of all functions in the top-level NumPy namespace containing load. You can run any file as a Python program inside the environment of your IPython session using the run command. Suppose you had the following simple script stored. Then you can execute this by passing the file name to run. The script is run in an empty namespace with no imports or other variables defined so that the behavior should be identical to running the program on the command line using Python script. All of the variables like imports, functions, and globals defined in the file will then be accessible in the IPython shell. If a Python script expects command line arguments to be found, these can be passed after the file path as through run on the command line. In the Jupyter notebook, you may also use the related load magic function, which imports a script into code cell. If you're using the Jupyter notebook, you can copy and paste code into any code cell and execute it. It is also possible to run code from the clipboard in the IPython shell. Suppose you had the following code in some other application. The most foolproof methods are paste and cpaste magic functions. Paste takes whatever text is in the clipboard and executes it as a single block in the shell. Cpaste is similar except that it gives you a special prompt for pasting code into it. IPython's special commands, which are not built into Python itself, are known as magic commands. These are designed to facilitate common tasks and enable you to easily control the behavior of the IPython system. For example, you can check the execution time of any Python statement, such as a matrix multiplication, using the timeit magic function, which will be discussed in more detail later. Magic commands can be viewed as command line programs to be run without the IPython system. Many of them have additional command line options, which can all be viewed as you might expect using question mark. Magic functions can be used by default without the % sign, as long as no variable is defined with the same name as the magic function in question. This feature is called AutoMagic and can be enabled or disenabled by AutoMagic. Some magic functions behave like Python functions, and their output can be assigned to a variable. One reason for IPython's popularity in analytical computing is that it integrates well with data visualization and other user interface libraries like matplotlib. Don't worry if you have never used matplotlib before. It will be discussed in more detail later. The matplotlib magic function configures its integration with the IPython shell or Jupyter notebook. This is important as otherwise plots you create will either not appear or take control of the session until closed shell. In the IPython shell, running matplotlib sets up the integration so you can create multiple plot windows without interfering with the console session. Now let's get on to Python language basics. Any text preceded by the hash mark is ignored by the Python interpreter. This is often used to add comments to code. At times, you may also want to exclude certain blocks of codes without deleting them. An easy solution is to comment out the code. Comments can also occur after a line of executed code. While some programmers prefer comments to be placed in the line preceding a particular line of code, this can be useful at times. You call functions passing 0 or more arguments, optionally assigning the return value to a variable. Almost every object in Python has attached functions known as methods that have access to the object's internal contents. You can call them using the following syntax. Functions can take both positional and keyword arguments. When assigning a variable in Python, you're creating a reference to the object on the right-hand side of the equal sign. In practical terms, consider a list of integers. Suppose we assign a to a new variable b. In some languages, this assignment will cause the data 1, 2, 3 to be copied. In Python, a and b actually now refer to the same object. You can prove this to yourself by appending an element to a and then examining b. Understanding the semantics of references in Python and when, how, and why data is copied is especially critical when you're working with larger datasets in Python. In contrast with many compiled languages such as Java and C++, object references in Python have no type associated with them. There is no problem with the following. Variables are a name for objects within a particular namespace. The type information is stored in the object itself. Some observers might hastily conclude that Python is not a typed language, but this is not true. Consider this example. The primary Python types for numbers are int and float. An int can store large numbers. Floating point numbers are represented with the Python float type. Under the hood, each one is a double precision value. They can also be expressed with scientific notation. Integer division not resulting in a whole number will always yield a floating point number. To get C-style integer division, which drops the fractional part if the result is not a whole number, use the floor division operator. In modern Python, Unicode has become the first class string type to enable more consistent handling. In older versions of Python, strings were all bytes without any explicit Unicode encoding. You could convert to Unicode assuming you knew the character encoding. Let's look at an example. We can convert this Unicode string to its UTF-8 bytes representation using the encode method. Assuming you know the Unicode encoding of a byte object, you can go back using the decode method. While it has become preferred to use UTF-8 for any encoding, for historical reasons you may encounter data in any number of different encodings. It is most common to encounter bytes objects in the context of working with files where decoding all data to Unicode strings may not be desired. Though you may seldom need to do so, you can define your own byte literals by prefixing a string with B. The two Boolean values in Python are written as true and false. Comparisons and other conditional expressions evaluate to either true or false. Boolean values are combined with the AND and OR keywords. The string Boolean, int, and float types are also functions that can be used to cast values to those types. None is the Python null value type. If a function does not return a value, it implicitly returns none. None is also a common default value for function arguments. While a technical point, it's worth bearing in mind that none is not only a reserved keyword, but also a unique instance of none type. A Turner expression in Python allows you to combine an if-else block that produces a value into a single line or expression. Here, true expression and false expression can be any Python expressions. It has the identical effect as the more verbose. While it may be tempting to always use Turner expressions to condense your code, realize that you may sacrifice readability if the condition, as well as the true and false expressions, are very complex. If there are any problems while following me through, welcome any questions on the email highlighted above. Thank you for listening and have a good day.